Azure Resource Manager, ARM, Templates, a deep dive. Azure Resource Manager, ARM, Templates, a powerful toolset that revolutionizes the provisioning and management of Azure resources. ARM Templates aims to unravel the intricacies of this technology, providing a comprehensive understanding of its capabilities and empowering both novices and seasoned professionals to harness its full potential. Understanding ARM Template Basics. Understanding ARM, Azure Resource Manager, Template Basics is crucial for efficiently deploying and managing resources in the Microsoft Azure cloud environment. The declarative nature of ARM templates, combined with parameters, variables, expressions, dependencies, and outputs, provides a powerful framework for orchestrating complex infrastructure deployments in a consistent and reproducible manner. ARM Template Structure and Syntax. The ARM template structure and syntax provide a powerful framework for describing, deploying, and managing Azure resources. The top-level structure and syntax of an ARM template includes the schema and content version fields. The schema specifies the version of the ARM template language, ensuring compatibility with Azure Resource Manager. Parameterization in ARM templates. Parameterization is a fundamental concept in ARM, Azure Resource Manager, templates that significantly enhances their flexibility and reusability. ARM templates. Parameterization involves defining parameters, which serve as placeholders for values that can be provided at the time of deployment. Variables and expressions. Variables and expressions in ARM, Azure Resource Manager, templates play a crucial role in enhancing the readability, maintainability, and adaptability of deployment configurations within the Azure cloud environment. Variables serve as named containers for values or expressions, allowing users to simplify template authoring and avoid redundancy. Expressions in ARM templates enable dynamic evaluation of values during deployment. Resource dependencies and ordering. Resource dependencies and ordering are critical aspects of ARM, Azure Resource Manager, templates, providing a mechanism to define the relationships and sequencing of resources during deployment in the Microsoft Azure cloud environment. Advanced ARM template features. Advanced ARM, Azure Resource Manager, template features empower users with a more sophisticated and versatile toolkit for orchestrating complex deployments in the Azure cloud. Integration with Azure's Role-Based Access Control, RBAC, system is an advanced ARM template feature that brings security policies and access controls into the template definition. Advanced ARM template features offer users a sophisticated set of tools to create, manage, and customize intricate infrastructure configurations in Azure. Security considerations in ARM templates. Several key considerations contribute to creating secure ARM templates. Access control and RBAC. A fundamental security consideration involves defining appropriate access controls through Azure's Role-Based Access Control, RBAC, system. Audit logging and monitoring. ARM templates should be configured to enable comprehensive audit logging and monitoring. Testing and debugging ARM templates. Unit testing with Azure PowerShell or Azure CLI. Unit testing involves testing individual components of the ARM template in isolation. Azure Policy for compliance testing. Azure Policy can be leveraged to enforce organizational standards and compliance requirements during testing. Debugging with Visual Studio Code and ARM tools. Developers can utilize Visual Studio Code, along with extensions like the Azure Resource Manager, ARM, tools, for debugging ARM templates. Scaling with ARM templates. ARM templates provide a declarative way to define and deploy resources, and they offer several features that facilitate scaling operations seamlessly. One primary mechanism for scaling with ARM templates is leveraging the flexibility of parameterization. Parameters allow users to define configurable values, such as the number of instances or the size of resources, at the time of deployment. Best practices for ARM template development. Parameterization is a key aspect of creating flexible and customizable templates. Maintaining documentation that outlines the purpose of each resource, intended configurations, and specific deployment steps ensures clarity for current and future users. Regular testing is an integral part of the development lifecycle. Conclusion. In conclusion, Adopting best practices for ARM, Azure Resource Manager, template development is instrumental in ensuring the success, reliability, and security of infrastructure deployments in Microsoft Azure. In essence, these best practices collectively contribute to the creation of ARM templates that are scalable, maintainable, and aligned with security and compliance standards.